Hello, everyone. We're in week 4 of Chemistry 1B. We're going to be looking at balancing chemical equations this week. There's not going to be as much paperwork for you this week, but this is a tough topic for a lot of kids. So I want to go through the notes pretty thoroughly. I have some online practice, but I know not all of you will have access to online. So I will also throw in a couple of practice sheets for those of you that might not be able to get online. I, however, recommend practicing this as much as possible because the rest of this course really heavily relies on you being able to balance a chemical equation. So you have in your Google Classroom or in your packet a sheet called Balancing Chemical Equations. This paperwork comes from the American Association of Chemistry Teachers, which is AACT, which is a group that I belong to and I've worked with. I think this is a really good model for you to follow, especially since it's long distance. So just to get started here, we need some background information and some vocabulary. Vocabulary is really, really going to be key. And when we talk about vocabulary, basically we are looking at chemical equations and we're looking at this chemical reaction. Now, if we were still in class, we would learn how to properly read and write this reaction. But that's a lot to do without me. But I'm going to give you an example. We would say that there are 2 units of aqueous silver nitrate and 1 unit of aqueous magnesium chloride yields 2 units of solid silver chloride and 1 unit of aqueous magnesium nitrate. Now, we're going to use these numbers out front, the 2 to 1 to 2 to 1. These guys here are called coefficients. Remember, just like math class, numbers that come out front are coefficients. We have some new symbols here. We have AQ, which means aqueous. Aqueous means that it can dissolve in water. So what I know about silver nitrate here is that silver is a metal, nitrate's a nonmetal, it's an ionic compound. Ionic compounds tend to be solids. I would say they are solids, and some ionic compounds may or may not dissolve in water. In this particular case, we know that silver nitrate can dissolve in water, so we tell the reader that it's aqueous. Now, you won't know at this level whether or not it's aqueous or not. I haven't shown you how to read the charts or some general rules, but when you're given a problem, when you're reading it, they may say, hey, this is aqueous. And when you see the word aqueous, you're going to know, you're going to use the symbol AQ, and that it means it dissolves in water. Magnesium chloride is also dissolvable in water. Silver chloride, however, is not. So we write that with an S. And S here means solid. And magnesium nitrate is going to be aqueous. So we have different symbols here. If we go to the bottom of this, you will see the second to the last bullet point that says after each formula there is a symbol that indicates the state of the substance. Solid is going to be S, liquid is going to be L, gas will be G, and aqueous means AQ. It dissolves in water. Now, you also may have heard that I use the word units. I said there's 2 units of, 1 unit of, 2 units of, 1 unit of. Now, this is going further. Units are used to tell the reader that you have an ionic compound coming up. A unit is just another way of notifying the reader that you have an ionic compound. Now, when we have a covalent compound, which we don't have anywhere in here, we don't use unit, we use the term molecule. So if I had 1 molecule of water, or if I had 2 molecules of carbon dioxide. And I'll try to use that as we go through. But again, I'm not asking you to write it out or to read to me. I'm really going to ask you to help me here figure out what these coefficients are that should go in front of each of the reactants. Remember, reactants are things that come first, and these guys here are the products. Right? So reactants produce products. The arrow can mean produce, The arrow can mean yield, forms. There's many different ways to use this word here, but as long as it has the same meaning behind it, we will be very, very flexible. Now, the last thing on the sheet, and I would really highly recommend that you read through these vocabulary terms. Take the time to look through them. I talked through most of them. But the last one, again, the law of conservation of mass, that states that mass of the reactants must always equal the mass of the products. It's very, very important as we move into the next few weeks. We need to know that the mass of the reactants have to equal the mass of the products. And the only way we can get the mass of the reactants to equal the mass of the products is if we know what the coefficients are for each of the reactants and the products. We have to be able to balance. Okay. Now, if you go to page 2 of the handout, there are some rules for balancing chemical equations. I would like for you to read through these. Okay? Read through them. To pause. Okay? If you would prefer to read them on your own, I'm just going to highlight. Okay? We are using coefficients to balance chemical equations. We must have equal numbers of one element on the reactant side and the same element on the product side. The coefficients must be whole number ratios. And more specifically, they have to be low whole number ratios. One of the hang-ups that I'm going to find with kiddos as we go through this is that, remember, there are 7 diatomic elements. Remember, have no fear of ice cold beverages. Okay, there are 7 of them, and when we go to write reactions, we must use the diatom. Okay? That's going to be extremely important when learning how to balance. Okay? There are some tips here. It says if the same polyatomic ion appears on both sides of the reaction, you're going to put a mental box around it and treat it as a single unit. Okay? We're going to balance the elements in the compound first. We want to start with metals, and then we're going to want to balance the nonmetals. That's a wonderful trick. Start with the metals and then the nonmetals. And then D, leave the reactants and products that are elements until the end. And I'll show you what that means as we go. Okay? So here's a sample problem. What we have here is solid magnesium, or a solid atom of magnesium, reacting with aqueous hydrochloric acid to produce a molecule of hydrogen gas and a unit of aqueous magnesium chloride. What we see here is that it's not balanced. And you're saying, well, how do I know that? Well, what I did here, or what this paper has here, is they made a box and they said, here's the reactants, here are the products. Okay. So we have magnesium, we have hydrogen, and we have chlorine. And we made the list. Those are the only 3 elements in this reaction: magnesium, hydrogen, and chlorine. And what I do is I look at the reactant side and I say, okay, let's look at magnesium. How many magnesiums are here? And we write 1. How many hydrogens are here? And we write 1. How many chlorines do we have here? And we write 1. Now we go to the product side and we see that it doesn't work that way, because according to this, how many hydrogens are here? There's 2. So if we go back to our box, our hydrogen has 2. If we go over here, we see our magnesium. Magnesium, there's 1, and chlorine, there's 2. So magnesium has 1, and chlorine has 2. And what the law of conservation of mass says is you have to have equal numbers on both sides. Now, these aren't representing masses, okay, but in order to get the masses to be the same, they have to have the same coefficient. And we see right from the go that right from the start, that magnesium, there's one magnesium, there's one magnesium. This is balanced. But when we look at hydrogen, there's one hydrogen for two hydrogens, not balanced. And that's why there's an asterisk next to these. It's saying they're not balanced in the chemical reaction, so coefficients have to be used. Same thing with chlorine. There's one chlorine on the reactant side, there's two chlorines on the product side. They don't match. Right? So what we have to do is figure out how we can get them to match. And this is a multiplication thing. What I would say is, for hydrogen, I have two hydrogens here. What could I multiply this one by to get 2? Well, you would say, oh, multiply it by 2. Yeah, multiply it by 2. And if I look at this guy here, what do I multiply this 1 by to get 2? Yeah, I'm going to multiply it by 2. So I need to multiply both the hydrogen and the chlorine by 2. And the only way to do that then is to go back to the chemical equation, and I'm going to place a coefficient of 2 in front of the HCl, because now I can distribute the 2 through. I have 2 hydrogens, I have 2 chlorines. I only needed 1 of my magnesium. I had to multiply this guy by 2 and this guy by 2, so I needed a coefficient of 2. I did not have to touch this side for anything. And so my coefficients here are 1 and 1. So we would say that our ratio of reactants to products would be a 1 to 2 to 1 to 1 ratio. And as we get going, we're going to write this as 1 to 2 to 1 to 1. And that is probably the easiest way to talk with another chemist about what's going on in their chemical reaction, is to write it in this format. Now, it's very important that you realize that they are low whole number ratios. 1 to 2 to 1 to 1 can't be reduced. If it was 2 to 4 to 2 to 2, then it would be reducible, and you would have to go and make sure the coefficients were 1 to 2 to 1 to 1. Okay. So let's look at another practice problem here. We have aqueous silver nitrate, aqueous magnesium chloride producing solid silver chloride, or a solid unit of silver chloride, and an aqueous unit of magnesium nitrate. So we're going to set up our chart. We're going to see that we have silver, we have Ag, we have NO3. NO3 is nitrate, and it's a polyatomic ion, and one of the tricks said, keep nitrate as one thing. We then have magnesium, we put magnesium in, and we have chlorine. So naming and writing your ionic and covalent compounds are going to be extremely important when you get to this part of it. Okay? So we're going to see how many on the reactant side we have, how many on the product side we have. So let's start with the reactants. How many AGs do we have here? Well, you've got 1. How many sets of NO3 do you have? You have 1. Remember, sets mean how many inside the parentheses. When I say parentheses, I'm talking about here. I don't have any parentheses around NO3, so that means that there is 1 set. We come over here to magnesium. How many Mgs do we have? We have 1. And here, how many chlorines do we have? We have 2. Now let's go to the product side. How many Ags do we have? Well, we have 1. How many Cls do we have? We have 1. How many Mgs do we have? We have 1. How many sets of NO3 do we have? Well, we see that we have parentheses here, so we have 2 sets, so we need a 2. Then we compare. Do they match up? Well, silver does, 1 to 1. But nitrate does not match up. So what do we have to multiply NO3 by? Well, we have to multiply the reactant side by 2. Magnesiums are good, but my chlorine over here don't match up. So on this one, we had to say times 2 to get this side to match that side. But now we have to multiply the product side here by 2, right, to get it to match up to chlorine over here. All right, that's going to probably cause a little bit of a headache. So let's go down and see what happens. I need to put a 2 in front of my nitrate, but if I put a 2 here in front of the nitrate, what does that do to my silver? Well, that doubles my silver. And so when I look at this, now I see I have 2 silvers and 2 nitrates. So what does that mean if I double now over here? What do I have to do to this guy on this side? Well, that means I have to multiply this guy over here by 2 as well. Okay. Well, so what I have then, and I'm going down towards the bottom of this page because I'm talking you through it. Remember, if I put a 2 silver nitrate here, I have to have a 2 in front of this Ag. All right. And now when I put the 2 in front of the Ag, how many chlorines do I have? Well, I have 2 chlorines. And what did I say that I had to do to the chlorines on this side? I have 2 chlorines. I think we should be okay. We have 2 silvers. We have 2 silvers. We have 2 sets of NO3. We have to distribute that 2 through. We have 2 sets of NO3. And over here, we had 2 sets of NO3. We had 1 magnesium. We have 1 magnesium. We have 2 chlorines. Here, we have to distribute the 2 through, so we have 2 chlorines. So my ratio on this guy is going to be 2 to 1 to 2 to 1. Is that a low whole number ratio? It is. All right, so what I have are some pre-activity questions for you. I would highly recommend that you pause here, try these, okay, and come back. Right, look at this first page and see how you do. Okay, welcome back. I'm going to fill this in with you. You have here phosphoric acid, which is H3PO4. You see here in the formula that you have 3 hydrogens. You have 1 phosphorus, and you have 4 oxygens. Here, this is pentanitrogen trioxide, covalent. You have 5 nitrogens. You have 3 oxygens. And on this guy, you have aluminum sulfite. You have 2 aluminums. Inside the parentheses, you have 1 sulfur. You have 1 sulfur, but you have 3 sets. So 1 times 3 is 3. Inside the parentheses, you have 3 oxygens. 3 times 3 is 9. Right. Now, I'm not going to ask you to write a word equation for this reaction, but if you did, you would say you had 1 atom of solid calcium and 2 molecules of aqueous hydrogen fluoride yields 1 unit of solid calcium fluoride and 1 molecule of hydrogen gas. Now, HF is a non-metal. I didn't call it hydrogen monofluoride because what you're going to learn later on, and I'm not there with you right now, this is an acid, so this is a memorized acid name. Okay. Is the reaction balanced? I have 1 calcium. I have 1 calcium. I have 2 hydrogens. I have 2 hydrogens. I have 2 fluorines. And I have 2 fluorines. So yes, this guy is balanced. What are the coefficients? My coefficients are 1 to 2 to 1 to 1. 1 to 2 to 1 to 1. The subscripts, right? The subscripts are the little numbers. There are no subscripts here, so it's understood that this guy is a 1. There's 1 hydrogen, 1 fluorine, 1 calcium, 2 fluorines, 2 hydrogens. Right? So if you wanted to, you could say calcium is 1. You would say the subscripts here is H1, F1, H1, F1. On CaF2, it's Ca1, F2. And on H2, it's H2. These numbers here are the subscripts. What is the state of each of the reactants? Remember, reactants are on the reaction side. So my states are solid and aqueous. So solid and aqueous. What will serve as evidence that a reaction has occurred? So this goes back to our notes from a long time ago. Okay? We said that there are some indicators of a chemical reaction. One of them would be that a gas was produced. Did we have a gas produced in the reaction? Yeah, we sure did. We had hydrogen, form of gas. Another thing that we said could happen would be a precipitate. A precipitate. Remember, precipitate is a fancy word for solid. Did we have a solid form? Oh, we sure did. So in this reaction, we actually had 2 different indicators that a reaction occurred. We had 2 indicators. Now, indicator 3 would be heat and light. Okay. So do you think that by forming hydrogen gas, heat and light was formed? No, it's probably just bubbles that you will see. Okay. And bubbles mean that you have a gas. And the 4th one is a color change. Now remember, color change doesn't always mean chemical change, but if this turned a fun different color, more than likely you had a chemical reaction. But the answer for this one is going to be that you see that you had a gas formed and that you had a solid formed. So these are your answers. So what I'm going to have you do is go to this simulation here. I highly recommend that you go and you play with it. And I'm hoping that you can be intuitive with it. When you get there, and I can show you, but it'll be really fuzzy on my screen. There are arrows up and arrows down. Right? These are the things that you want to work with, the arrows up and the arrows down that come in front of hydrogen and nitrogen. Okay. Play with it. See if you can figure out what's going on. I mean, I can try one with you here. I have it ready to go. I just don't know what the quality is going to be like on your side. Okay, so when you get there, it's going to look like this. And I would like for you to do the introduction. Okay. And what I'm talking about here is the arrows up and the arrows down. And you are going to click on the arrow up, and that's going to show you nitrogen. Well, there's 2 molecules of nitrogen there, and you have 1 hydrogen, which you have 2 hydrogens there. Now, that reaction, these reactants are going to form this product. The product is ammonia. But you only have 1 blue N, and over here you have 2 blue N's. And you need to make sure that you have equal numbers. So what I'm going to do is I'm going to hit the arrow up. So I'm going to bring in 2 ammonias. Now I have 2 blues. I have 2 blues, so those match. But my hydrogens don't match. I have 2 hydrogens here, and I have 3 hydrogens here, 3 hydrogens there, for a total of 6. So if I want to get 6 on this side, I know I have to multiply 2 by 3. So I'm going to go up to 3. And the yellow lights come on which mean, yep, you did it. You have it. So there are some directions for you to follow in the packet. I highly recommend at this time that you try those. So I think I did hydrogen and nitrogen for you, but then there's water, right? Then they have methane for you to do, or something. I didn't really read it. But try through. There's some other things for you to do. There's levels 2 and levels 3 for you to try. Get a little real, okay? Write down what you get for your result, right? And that's what I would like for you to submit for me for this week. This is one where you're going to have to ask questions if you need help, right? Don't just tell me I don't know how. You've got to give me something concrete because we're working remotely, okay? And if we need to Zoom, okay, we can set up a time for a bunch of us to get together, okay, and talk about it too. Okay? Have a great week. We'll talk to you soon.